Now we have our setup, which is done. So you can see here, this is the original model, but when you press setup, it shows you the stock size. The stock is that little yellow thing. Next up are the actual toolpaths. So so you have your big piece of stock, right? So currently, let's see if I can I simulate this? I don't know if I can. Yeah, there's no toolpaths to simulate. Okay, basically, so what Onshape currently sees is you're starting out with this big rectangle. With this yellow rectangle, which you want to turn into your model. So how would you do that? You use different types of operations. Everything we do is 3D, or is 2D, sorry. 3D is like all, I know it's X, Y, and Z, so it seems 3D, but it's really not. 3D is tremendously complex. But so everything we do, it's 2D pocket and 2D, or sorry, it's bore and 2D contour. Those are the two important ones. So bore is obviously for like making holes and things. Spherical cuts, yeah, same thing. And then 2D contour is tracing around shapes, as you can see in this little diagram that's popped up. So, I always do bore first and then contour, because what you can do is, so let's say you have a rectangle, right? Then it allows you to drill the holes into it, and then you can screw those holes down, and then you can cut out the shape so that your part doesn't become loose, right? So what I'll do is, so I have these things called templates. So what that is it's a preloaded template. It's exactly what it sounds like. It's a 2D bore, and it has the correct speeds and feeds and everything like that. So what I'll do is I'll right click, I'll hit create from template, and then there's a few, don't worry about it. It's called final brace bore. So I'm gonna open this up. So this is the inside of the toolpath. I guess, like, I don't know, it's the details of the toolpath. So here are your feeds and speeds. These are vitally important. This is, so in a 3D printer, right? Let's say you just want to go like 50 millimeters per second. It's one single setting which you change, right? To go fast or slow, how fast the printhead moves. In CNCing, it's infinitely harder, right? You have how fast the tool spins, how fast the gantry that the tool is on spins, how fast the tool goes up and down, in and out. So much stuff. So what I've done is I spent way too many, like a year or two, just going through online forums and then just doing testing myself and optimizing it to the tools we have here at 8590. And so basically these speeds are really good. They work tremendously well. They're not sluggishly slow that it takes forever to do this single part, but they're not too fast that you're churning through drill bits or end mills and breaking them and costing the team a fortune. So this is what I would go with. And so since it's a template, it already has the tool preloaded. So for all of our holes, if they're reasonably sized, I use an 1/8 inch end mill. 1/8 inch, it's listed here as 3.175 millimeters. I don't know why, that's an 1/8 inch end mill. If you have like massive holes or something, let's say you have like a 1/4 inch hole, you can choose to do it with this 1/8 inch end mill, or you can do that as a contour, because the contour uses a 1/4 inch end mill, so that might be a little faster. Or you have to do some weird shape cutout or something. But for a traditional bolt, what am I saying? For a traditional hole for like a bolt or something, that's preloaded like this, that's reasonably sized, an 1/8 inch end mill is fine. Now, so this is boring, right? So this is doing all the holes, because you can see here under cam it says bore. So this is our boring toolpath. So I'm going to go and select all these holes. So it turns green. And so what's happening here is, actually it's unnecessary, you don't need to know. Basically, it's just tracing the toolpath and it's optimizing it as you increase. So I'm going to select these, a little tedious, but whatever. Bam. Okay, there are all of our holes selected. Nice. And now, reverse order, it doesn't really matter. It's just if it goes in or out, into out or out to in. And then next up is heights. This is really also quite important too. So if you see here, so this blue line right here, this is your bottom height. I have it offset right now. That was for something else. So I'm going to set that to 0. So basically, that is like the bottom of your stock and like how deep it should stop drilling to. Top height, that is going to be the top of your stock. That's fine. You can also set it here, stock bottom. And offset is if you want it different, like offset physically from your thing. Don't worry about that. Retract height. So basically, retracting is if it does a hole, it's going to lift up, move over, and then go down to drill another hole. basically the point of retract is you don't want to make it too high or too low. Just setting it decently high is fine. We'll make it 0.1 inches. That's fine. Oh, whoops. We'll go. Oh, this video is 15 minutes. Okay, we should speed this up. Clearance height, basically, clearance is to make sure it doesn't run into anything. It goes to this height. Just put it decently high up. You'll be fine. Don't touch any of this stuff. Bam. Oh, it's because when I accidentally hit enter, it didn't save. Okay, that's fun. I'm gonna do this again quickly. Bam. Okay, we're good. Nice. Now I'll go a little faster. Create from template. So now we've drilled out the holes. Now we want to cut the shape out. So I'm going to go down to final brace contour, blah, blah, blah. Don't worry about the name. It was just leftovers from this thing. Okay. And I'm going to open the toolpath. So contour cuts it out. So here you can see it's with a 1/4 inch end mill, a little bigger. And so these feeds and speeds, keep them all the same. Obviously, if it's the metal is screeching or something, you can turn the speeds down, but do that with the controller, not in the template. And so here, the geometry, we're just going to select the outside I want to cut. And then the heights, same deal. I don't know why I have offsets. We'll just zeros at the bottom. Top height. Everything else looks good. Passes. Okay, this is pretty important. Multiple depths, so you're not cutting the whole thing out at once. So the roughing step down is it does a layer and then goes down and does another layer. Usually you want this to be ideally less than half of your end mill diameter. So our diameter is 1/4 inch, so 0.25. So it should be less than 0.125. I'm gonna set this at 0.1 inches. Pretty conservative cut, but that's fine. Ramping is good. So rather than just going directly down into material and then going sideways, this slowly goes down and sideways. I'll show you later on. But this is better just for preserving your end mill life. Press OK. So now these two are done. I'm going to quickly simulate this. Right click on my setup, hit simulate, and then I'm going to hit show stock. So you can see here, this is what the computer thinks we have originally. Or this is what we start out with, really, just a big block of metal. And then here's our 1/8 inch end mill. It's doing all the holes, and you can see it's doing that little helix. That's also called a ramp. It does, it's a setting in the template. So beautiful. It's looking amazing. Hasn't ran into anything or the holes. It hasn't skipped one. So just checking. And now this is our bigger 1/4 inch end mill. So you can see here, it does quite a lot. And then just 2 passes. Beautiful. Looks fine to me. I'm gonna hit close. And then pause real quick. I have to get my USB. Okay, nice. So remember I said previously that this is just generic G code that this will make, and we have to run it through something that translates it and then puts it into our machine, that our machine is able to read it. So it's called post-processing. So once you've made all your toolpaths and you feel you're pretty happy with them, what I'm going to do is right click on this one, and I'm going to do them separately. So I'm going to right click on bore, and I'm going to hit post-process. So now here we have, this is your post-processor. This is very important. No, sorry, it's called an NC program. But what it does is it converts generic code, like it says here, generic, to Axiom Auto. And so this file, it's also in our Google Drive. You can access it. So this is really important. And so the output folder, I want this outputted into this file or this USB. Beautiful. I'm going to hit post. And then I'm going to hit save. It's called 1001. I probably should have renamed it. It's fine. Let it load. So, and then it opens up the G code. So this is physically what the machine sees. So as long as there's no errors or anything, if there's an error, it'll tell you, and then all this G code won't appear. But this is actually what the machine reads. So here you can see X, Y, and Z. So that's pretty cool. I'm gonna change the file name real quick. We'll change it to bore. Pierce. Don't worry about the other files. Muy fast. I had to run something pretty fast, and I was out of names. So we'll call this bore. It's always bad capitalization, whatever. It's always good to name your files. And then 2D contour. I'm gonna do the same thing. Post process. All this is fine. Under program name, I'm gonna just call it shape. That's what I call contours. Post. Same output. Beautiful. It doesn't say big blaring error, and there's G code. And that should be all of it. Just under 20 minutes. Nice. I'll see you on the machine.